Hey there, welcome to episode 134 of the Quaggling Sand audio program. I am your host, Dan Hugo, as usual. We're recording this at 10:24 in the morning, Pacific Daylight Time, of course, here in Greater Vegas, on Wednesday, June 3rd, 2026. Today's title and topic, Engineering Sans AI. That means without AI. If you are new to the Quaggling Sand audio program, let me tell you, quaggling sand is a technical term I coined when I was very young. You probably know it better as pins and needles. In this context, it is a swirling dust devil of sorts in the mind, bringing about recollections, stories, tales, maybe something you'll find interesting. The show is typically, 134 episodes worth so far. Typically a monologue, an audio essay, no guests required. So hopefully you'll find something interesting or entertaining in this or any of the previous episodes. Give them a listen if you like. And so let us begin on this lovely and soon to be very warm Wednesday. We normally do publish new episodes of Quaggling Sand on Wednesdays, usually in the morning, so we'll see if we can make it. On that note, hopefully wherever you found this audio program, you're able to locate the episode description, which contains the show notes, including a brief summary, which I will read to you. The usual links for every show, the two. It has been two for a while. It used to be more, but now it's just the two, keeping it simple. And then we'll get on to the fun part. So, the summary of today's episode, pilot or engineer or pilot. It came down to glasses and the way the U.S. Air Force worked at the time. So engineering it was and is. And now purveyors of AI want you to believe pursuit of engineering and technology is not worthwhile. I don't know if they realize how they were able to achieve what they have with their AI companies. It wasn't pilots. I don't think I mentioned this anywhere in the show, but the United States Air Force, at the time when I was considering some path to flying the big jets, I was totally into flying. They did not allow surgically corrected eyesight. So you had to have natural 20/20 or better. And I will say the last time I went and had my vision checked for my Air Force physical, for my submission, application to the United States Air Force Academy, I was at Luke Air Force Base, and the person, I assume he was an eye doctor of some sort, they do the full dial of your eyes, full measurements of, so they measure focus of your lens in a relaxed state and all this. He said, I'm going to give you 20/20 today, and that's probably the last time anyone's ever going to write that down as a vision test result. So consider. I was like, wow, okay. So here we are. The links for the show, as usual, nothing special today. Quaggling Sand homepage. Quaggling is spelled just like it sounds. QUOGGLINGSAND.com. I've been saying this link forever, and yet the website is no more or less lovely than it has been, mostly because I have too many things. But eventually, in the future, or if you're listening to this then, way back here in the past, my hope was that eventually it would just catch on, having the link floating around in this simple 2-link doublet, which might become one link eventually. I mean, that's the way it should be, right? The second link, profile page, linking everything, is my 5-year and 2-month-old buymeacoffee.com/Dan Hugo profile page. I use it as a free-form a link tree of sorts. So there's links to all of my audio programs, all of my projects, most, I guess. Some affiliate links for things that I actually use if you are interested in any of that. There's some biographical information, and you don't have to buy me a coffee. You can if you want. Any proceeds that flow through this portal, this platform, do go towards the purchase of coffee, though. That is what powers all of my endeavors. Buymeacoffee.com/Dan Hugo is also the home of the Buy Me an Update audio program, which publishes every Monday morning. It is a 5-minute or less update It is a rundown of the previous week's audio program topics and any news and announcements into the future. It used to be published exclusively at buymeacoffee.com/danhugo/posts. But now, because that's not the best way to publish a podcast, it is published I just did 1 hour this week, but usually 2 hours later, it publishes in the usual places via Spotify, the Spotify for Creators platform, which I'm not a huge fan of, but it does sort of work sometimes. So, but the quaglingsand.com homepage is ideally to be the primary point of publication. So that's why I'm trying to get that link out there. Into the future, it will be the place to figure out where the rest of the stuff is. So there you go. No other links for today. So let's get started. With the early years, I've always been interested in how things work with actual books with that title, at least one with that title in the mix, and taking things apart, not necessarily putting them back together. Generally exercising my intellectual curiosity from a very young age. That I learned to read so early was definitely an enabling achievement. I think I was like 3 or 4, maybe 3, something. Enabling achievement back then. The library card is up there on that list too. I did an entire episode of this very audio program called Meet Me at the Library. I went into my my history with those. The library was always a good place. Nowadays, it's usually an empty place. Don't they just have Kindles on the shelves now? I do have a library card here in Vegas, and I do check out books frequently. I have one depressing book right now. It's I can't remember. It's Another Fourth Turning or something. It's the update to the cyclic history book. It's actually pretty interesting. We'll talk about that another time. I was always interested in flying and aircraft and how they worked, but also always interested in technology and how pretty much everything else worked. I would have many opportunities to be around aircraft and computers around the 7th grade or so, starting then. More computers than aircraft exactly at that time, but I would have more aircraft time soon enough. But these were formative years, and hands-on or direct interactions were very valuable, and so the computers started influencing just through direct contact. And I would do, whatever I have to do to get access to a computer at the time, they were not in our pockets, certainly back then. By the time I was headed to high school, I had a computer, the Apple IIe, and a lot of posters of aircraft on the walls of my bedroom. Perhaps things would have gone very differently if those were swapped, but these were still the days of library books and my big purchase, my 1200 baud modem. This would come, what was my sophomore year of high school, I think it was. Saved up my money working at McDonald's. I would go to computer club meetups, the Arizona Apple Desert Menagerie, later known as the Arizona Apple Users Group. I've talked about that as well. The days of special interest groups. They should make a comeback. And taking the bus to school, city bus. These were simple and very manual, hands-on times. The bus was a part of this whole picture, although I will not talk about it too much because it was just another thing that kind of fit into this, I'll call it low tech. I don't know. It was just getting around required a certain amount of planning and awareness. What time is it? Where's the bus stop? What time does the bus come? Does it take me where I need to go? Is there a connecting bus that I have to get a transfer? Just knowing there was no Uber. There was no Lyft. I didn't have a car yet, of course. So before college, sometimes that's called high school, some more stuff. Through my high school career, I participated in the AFJ ROTC program, that's Air Force Junior ROTC, at Sunny Slope High School in Phoenix. I've talked about this previously as well, with my intent being the pilot program in the United States Air Force, of course, either by way of an Air Force Academy appointment. I came close. John McCain wanted to send me to Annapolis, but it was very early in the process, and I kind of what the vision news was like, why go through this and then not get what I was looking for, or through an AFROTC scholarship, which I did get. Along the way, I certainly pursued the math and science track doing well in both, I think, if I recall correctly, and learning more on my own about computers, programming, and other such things. The computer facilities at Sunny Slope High School were minimal. The teaching was, I mean, it was the early days. It was between 1989 and 19, no, I'm sorry, it was between 19, college. High school was up through 1989. So not a lot of the highest tech. They had Acorn computers, I believe it was, in the computer lab, the one computer lab at my high school. Working at McDonald's, an adventure I have gone over previously, I learned the joys of cooking by hand, which sounds funny today, but at the time, the store in which I worked in the mall, Metro Center Mall, was not overly automated. Other than timers for cooking, they were pre-programmed cycle timers. So it's like you hit the button, it would go off in 20 seconds. If you're cooking burgers, 10 to 1s, go off in 20 seconds. Then it would go off in like a minute to flip it. Then it would go off in a minute to pull it off the grill. That's it. It was all you otherwise. Not only it was not overly automated, and same with the French fries and the fish fillet. Everything had timers. That's it. That was the extent of the automation. You had to literally do the rest yourself, which is the way the world works usually, right? And we had cash registers, which would give the change amount. So that was probably the most technology we had to play with. It would tell you, you'd touch the menu item. They were not pictures; they were words. So we were still trailing edge. But you would tap in how many Big Macs and how many French fries and all that. On a not really a touch screen, but a programmable touch keyboard type thing, square, kind of a square. Anyway, doesn't matter. So you'd touch that in there. It would give you a total. You'd tell the customer the total. They would give you cash. We didn't take credit cards back then, and then they would tell you how much change you give. So piece of cake, right? Didn't have to worry about adding or subtracting numbers in your head. Although, when the mall location was occasionally busy and then sometimes extremely busy, so when certain shopping seasons would come along, certainly the winter season, they would pull these registers out of the storage area, the back halls of the mall. So they'd get these, I think they were called Suida, the company that made them, the Suidas. And these were old style mechanical cash registers, no help at all. You would type in numbers and hit an adding key, right? So Big Mac 265, and then you would get a receipt. But it was all mechanical, no advice on change or anything. So you had to be aware of how cash handling worked. That was a good habit to learn, and it's one that I don't see anymore. It's always funny today in modern times. You can't hand someone a penny anymore. I guess those days are over. But if you like, oh, it's here's 2 cents to me. Like what? What do I do with this? So yeah, nobody knows how to do with that. One of my favorite of all time. Someone, it was her family's coffee shop that I used to visit in downtown Sunnyvale. Someone gave her a $100 bill, and it was for a coffee. Right. And it was the end of the day. So they happened to have a lot of cash in the register so they could cover it. So that was not the problem. The problem was, as I see it, the customer gave them the $100 bill, and it was, call it $7 or something. So she pulls out $93 and says, here you go. Doesn't count. It doesn't just, hopefully I didn't have a couple of 20s stuck together. So it's a good idea for both sides of the transaction to be able to know what the correct change amount is and to count it back so that you know you're correct and the customer has some sort of confidence that you're correct and so on. So win-win, except not anymore, I guess. Working with other people, and these were high school aged peers, and interacting with our decidedly manual tools was the way. That's it. And as is so often the case, working in fast food is a reasonably important and useful learning experience, best not repeated too many times. So if there's one thing you learn working in fast food is that you don't necessarily want to work in fast food, but it was a good experience. It probably led in some way to my interest in food trucks and my ability to work on food trucks. Pretty easy. It's not hard. Not hard. There were no cell phones back then. I had my modem, which I mentioned, and I waited to get the price reduction because Hayes had just launched their 2400 baud modem. So the 1200s were going super cheap. So I was finally able to get online. So yeah, I had my modem was the big thing. I traveled by bus and later by bug. It was a decidedly not automated time while I was pursuing the beginnings of making and working with that automation future. My time with computers when I could get it and when I finally did have a computer. Especially as I discovered that my Air Force pilot days seemed unlikely with my eyesight becoming what it would become. And I still wear glasses today. It didn't magically get better. So that one school, I should have put that my high school counselor had mentioned during my first year at Sunny Slope. What was that again? Harvey Mudd? That would be the one. So college was just a hint at what was to come. This was a nerd school, to be sure. Of my 151 students that attended the opening day, first day of school, for my class, I believe it was 118 graduated, and I believe it was 70 or 60, 69 or 70 engineering, 13 chemists, like 8 physicists. So it was a small school, definitely leaned towards engineering, but also pure science. There were some biologists. I think they had just introduced the biology major. So we were pretty nerdy, a nerdy bunch. I think it was nerdier back then than it is now, to be honest. Who can say? I know there are still some smart people coming from my alma mater. We just call it Mud usually. So there are smart people coming out of Mud, even though they added liberal arts majors. So you can actually attend Harvey Mudd College and get a degree in something other than any of those topics I mentioned. I think they added a computer science degree in there, but then they also added English, maybe. Maybe you can get an English lit or history major from Mud for some reason. Who knows? Anyway, way back then, there was a rather intense focus on what is now called STEM, science, technology, engineering, and mathematics. And of course, I was pursuing my engineering and economics concentrations for my engineering degree with the minor in economics. That's how that works. It all made sense. We had a library with paper books and magazines and access to what would someday be the internet. In its fragmented days, we actually had access to BitNet, if you remember that. You could contact your friends in colleges across the country. Email. Crazy. And a reasonably interesting and useful amount of Unix-ish computing power at our disposal. I preferred the J. Arthur machine, which was running a parallel processor version of Unix, which I believe it was called Dynix. I've talked about this in a previous episode. It was the sequent balance computer. I think it had like 4 386s or something like that. Or maybe the balance, maybe the symmetry. They upgraded it. It was good times. So having all that computing power at our disposal was crazy. Not like today where, yeah, your modern phone is probably more powerful than the balance and the symmetry. Maybe. But yeah, we have access to so much computing power, so it's crazy today. All for AI, of course. All of my work in college was either manual or automated through manual interaction. That is, we would write our own code to do things and so on. Learning about operational amplifiers, build up a simulation model in PSpice and see how they work. Building a robot, learn microcontroller assembly language. Did that. Building some speakers, apply resistor, capacitor, inductor models to crossover design and learn acoustics to build a bass reflex enclosure. Did those. Spreadsheets, some MATLAB, some coding, hands-on machine tools like metal lathes, metal end mills, wood lathe, sheet metal bending, sheet metal brake, all of that. There was no CNC in the shop, by the way, computer numeric controlled. So those were all manual too. And part of one class, E54 experimental engineering, where we did have to make a screwdriver, a hammer, and a tool tray to fit into our little red toolbox. That was on our own time. No CNC, all those machine tools I mentioned. But also we had to do some drafting. We had to be able to draw with a pencil on paper. And there was much chagrin there. Why do we have to hand draw mechanical shop drawings? There's CAD. And the instructor for that part of the class, who was, he's probably not around anymore. He was already ancient at the time. It was all about learning the way before we learned the shortcuts. So to be honest, looking back, that absolutely makes sense. And it kind of cuts to the core of what I'm saying today, which we'll get to in a moment. I actually heard about neural nets from some of my computer science colleagues. Remember, they just had introduced the computer science major where you could pursue an independent program of study. There was one named Taj. I don't remember his last name, but he was a nice guy, kind of quiet, kept to himself. He was working on neural nets. So I remember him describing specifically the nature of the input, the output, and the multiple hidden layers of a neural network. And this was in the early 90s. These make an appearance in our modern AI chaos, of course, when you talk about all these GPUs that you need to do everything called AI. It's because they multiply and add numbers together. And so neural nets are, it's just a bunch of multiplying and adding. You are scaling. When you hear the term open weights, these numbers are used to scale or weight the inputs. So the input signal comes in, you multiply the scaling, and then as it traverses each layer of the hidden layers, you're adding and multiplying and adding and so on. And so you need to do that as many times per unit time as possible. And that's where you get trillions of dollars of expenditure. So yeah, that's sort of the fundamental stuff that makes up what's going on now. But way back then, there was nowhere near enough data, nowhere near enough compute power, and nowhere near the functionality of the model infrastructure which exists today. So you can look up what a transformer is. It's the T in GPT, generative pre-trained transformer, I believe, if I remember correctly. So the general idea of the transformer is what really kind of makes the natural language stuff work. And look where it's gotten us. Google wrote the paper on transformers, and I cannot remember what the title is, but it's fairly well known. The beginnings were there back then. It was the start of the start. But the interesting parts for me were the things I was learning, like 10 times of what I was doing on my own when I was younger, maybe 10 times, maybe more. Harvey Mudd College was a difficult place to get through, especially in 4 years. Not everyone did. I did. We all had our individual challenges, but looking back, I think I did ultimately make the right choice for my learning style and whatnot. I still wonder about MIT. That would have been a wildly different path, and that's if I would have been accepted. But Mudd it was and always shall be. And that's okay. That's fine. So learning by doing, though, that's the crux. That's where this has led. So the thing we all took from Mudd, I think just you kind of had to, and this was back then, I don't know about today. If we were paying attention, the thing that we took from Mudd was that learning how things work is ultimately useful to learn how other things work. They used to say you learn how to learn, and that's also true. Learning is a journey, perhaps, where different parts of a project, for example, may be built from things that are understood. The parts that you may or may not understand yet could be, understood based on the previous understandings. And then they can be understood with some research sometimes, so based on what we already understood. So you're taking a combination of, this is a combination of these things I know. Maybe this is a combination of the things I know plus a little bit more things that I have to figure out. And then the really interesting parts that required rolling up the sleeves and trying it out, like, I don't know how this works. Let me take it apart. I was ready for that one. And then figure out how it can integrate or fits into the plan, the project, the different parts, how they're going to fit together, talk to each other, interact, etc. Maybe you have to reassemble some things. That part I was not quite as adept at. Whatever the thing is. So it could be anything. It was not uncommon for me to accept a position, and this was out in the working world after Mudd, to accept a position or to be accepted into a position for some company where the exact description was not quite carved in stone as to what I would be doing. And where at any given time, I may not know how to solve some problem or accomplish some next step. And that was totally fine. It would always be, do you know how to do this? Well, not yet, right? Like, it doesn't have to be yes. It doesn't have to be a permanent no. There's always a way to figure out how to do it. And that's basically what we learned at Mud. So there's a lot of like hands-on and not knowing quite what you're getting yourself into. And everything moved very fast. Somewhere in a previous episode, I learned about I talked about how I learned about my first real programming job. It was the summer after my first year at Harvey Mudd College. They were still teaching Pascal. And if you recall from yet another previous episode, I learned Pascal when I was in 7th grade by working with a friend of a friend who was vision impaired. She was not totally blind, but legally blind. And so she really couldn't work with the keyboard and the terminal and all this. I mean, she could barely see anything. So I learned Pascal at Grand Canyon Community College on their VAX. Harvey Mudd College also had a VAX. So I learned how to compile code and to debug it and all that stuff when I was, 12 years old, something like this. So, 7th grade is a pretty important time. It's a time to start learning some interesting, all the stuff that you think you might be interested in. Start then. You got 10 years. Then you're out of college and on to the next thing. So I already knew Pascal. We learned Pascal some more in college using the same VAX that I had been learning on before. But this time the job called for learning the C programming language. Could I learn it? He said, do you think you can learn it in a couple days? And I said, sure. I basically spent my summer job. I learned the fundamentals. I understood the syntax and all that, but the actual way to do it, anybody can crack an egg. That's on the first day. Making an omelet maybe comes a couple of weeks later, right? And in the end, I learned all about how the compiler worked. That was what was happening in memory, stacks, heaps, branching, the whole nine, by stepping through a source debugger that happened to be a part of the compiler, the Power C compiler set that they were using at this company. It was on. I had an IBM PC XT running at 4 megahertz, I think it was. By stepping through a source debugger, which would show me the source code, the corresponding assembly language that it was compiled into, and the state of various registers and so on, so you could watch all these things moving step by step, one instruction at a time. Basically, I was learning from the bottom up. Like, this is what is actually happening. The same was true at Intel. The first time I worked there in Chandler, Arizona, where I learned how an X scale, which was Intel's ARM license deployment and product, the X-Scale, how it was working in development by stepping through a substantially more expensive emulator during the pre-tape out development process of a new ARM part, a new X-Scale part. It was ARM architecture. So this would be true across many roles I held through my career, mostly in Silicon Valley, where the unknown parts were the ones that made the pay better and the brain bigger. And that's where I was applying all these different learning methodologies and experience learning. And I don't know how this works yet. And so that's where you begin, adding to your mental library, which for some people was more of a showstopper. Like, I don't know how this works. And that was it. Throughout my entire career, it was, I don't know how this works. That's the interesting part. So whatever happened to those days? I am learning. I'm leaning. I wrote leaning. I read learning. I am leaning in on the actual tech a lot here. But something else we learned in college, and which is essential both inside the work environment and out in the real world, is communicating with people. Now, I am not known for I am not known for brief or for brevity. I am known for going on at length, maybe being overly detailed, but I have come a long way. It used to be worse. If you can believe that, listen to the rest of my podcast. But I learned this by doing it, by you just talk to people, you talk to a crowd, which I was not really good at when I was in college, but I started improving there. It gets easier the more you do it. Writing emails, writing papers, writing reports, writing specifications, everything. You just start writing and trying to express an idea that others will consume and understand so you can collaborate with them. Writing and speaking are both important. I figured out the public speaking part once and for all by trying out open mic comedy a few times. I've talked about that in a previous episode. But I've always been fine with the writing. I'm good with writing. I think this is important in particular because anyone, engineer or not, is going to have to write something at some point in their travels. And AI tools are turning the art of expressing a thought, as a chef might, into a TV dinner popped into the microwave for a quick, though often disappointing pile of snacks, food, or victuals. Yuck. I don't know if that analogy works, but when you really think about it, nothing goes into a TV dinner. Nothing goes into AI spitting out vectors of text. So today we're in modernity. AI has only been around for a couple of years. ChatGPT, OpenAI, launched its first public tools at the end of November 2022. It was November 30th. Barely enough time to get an undergraduate degree. We're not even to November 2026 yet. So not even 4 years. And yet AI is credited with making or breaking. By the way, I have M dashes in here 4 times in this, in my notes, all inserted by me. So making or breaking the world. Too much science fiction has crafted the fear, uncertainty, and doubt around, Skynet and all this. But the financials and the larger economic impact of this bubble are probably the big concern. There are the naysayers and they're arguably anti, but they're certainly not impressed because, as it turns out, there's no data centers being built. There's a memory supply crisis, which is driving the price of home-built computers like the one I use, that I built myself many years ago. Nowadays you don't even need to build a new computer. I'm not a gamer. So you build a computer and you're like, this is pretty good. I don't really need to build a new one. I used to build a new computer every year and a half or so. Moore's Law. Production by a street. Somebody needs a little silencer on their car. So yeah, everybody's afraid of the science fiction part, but it's really the economics part. I think that will be a problem. So we'll see what unfolds. There's APIs announced. Anthropic plans to go public soon, and OpenAI soon after. SpaceX, of course. Time to get your money out of the S&P 500. But first, AI. It has become a completely generic term for some tools and methods which are profoundly useful and which can be used for real scientific discovery and technical design, maybe even playing chess or Go in unique ways. In fact, those were huge milestones. The Go stuff from the Google DeepMind group, but they acquired the company. When Go became creative during a particular game in a match with a Go champion, it did something completely unexpected. So the human counterpart was like, that was dumb. And it turned out to be the beginning of the end of that round with the DeepMind winning. So that made a lot of headlines because maybe not where you read news, but it made a lot of headlines because suddenly the computer was doing something creative or unexpected. These are not large language models. These are very different tools. You can do deep learning, machine learning, classification. Image generation is not large language model. It's convolutional neural networks usually. But try searching for that. AI and CNN, you don't get convolutional network anymore. You get the news network. So not everything is ChatGPT, although ChatGPT as the front end, as the thing you interact with, integrates a lot of these things. But a large language model is not the same as classifying proteins or determining antenna designs. That's where you're using actual mathematics and you're doing actual modeling and so on. So when you hear about models today, it's mostly the pre-trained weights of those neural nets I mentioned. So yeah, not everything called AI is identical to everything else called AI. And this can be confusing because some people will think, oh, they're using AI to conduct medical research. Well, you know how reliable ChatGPT is. Well, totally different, hopefully totally different. I have I have suggested that there is no medical degree hanging on the wall of ChatGPT. So you don't know exactly how it was trained, but if you are doing protein research in a lab, you're hopefully not using it. You're using PyTorch or something. You're doing some deep learning on data. This leads to bad advice, though, by people who make simplifying assumptions about what AI is in a variety of contexts. Everything is just AI. It's just magically all the same thing. A long road of learning ahead where people figure out what these tools actually are. And ultimately, that's probably not going to happen. So everything will just be a black box, as we call it. I don't know what's going on inside, but it's AI. And it could be any variety of tools, some infinitely useful and some bubblicious. I have sat with younger software developers recently in the past couple of years who had no idea what they were doing or how they were going or how they were working. Or how what they were working on actually worked. I wrote how what they were working actually worked. That's the problem. It screwed me up. So the days of learning how underlying systems function from the bottom up, as I had done. Now, I'm not saying I was this is the way, but it was certainly educational and useful, extremely practical to know these things. Like if you're a car mechanic and you've never kind of gotten under the hood of a car and seen exactly how everything works with a car engine and transmission and everything, you really don't know, right? You can't just plug in your EDC2. Is it EDC? No. ODB2? Whatever the plug is under that, I can't remember now. There's a plug under the steering wheel in most cars, which attaches to the sensor system and all that, the car OS, and you can pull all the data about your car and it's, how it's running, any problems. The check engine light is only the beginning, right? But if you've never actually investigated how the car works and only looked at the debug port, I think it's ODB2. Now I want to know. ODB2? Nope, that was not the correct spelling of that. ODB2. Onboard Diagnostics 2 is the standardized computer system built into all cars, manufactured after 1996. So yeah, now you technically don't need to ever touch the car other than plugging that in, but that's not really how you learn how cars work. And I guess those days are changing rapidly today. So yeah, people don't learn how things work anymore. They just accept that surface level. Not everybody, of course. All this comes about by people knowing how things work. So we're not the Eloi just yet. If you're familiar with the time machine, don't be a Morlock either. Try to be what's the time traveler guy's name? Is that total? This one I should know. Stupid. What's his name? The novel by H.G. Wells. The time traveler. Doesn't he have a name? What? I'm totally off topic here, I know. But I must know. Oh, they gave it his own name, H. George Wells. He was the time traveler. I think I knew that, but I don't have room for all this trivia anymore. Those days are fading. But yeah, so if you are H.G. Wells, if you're Dr. Wells, if you're the time traveler, be that guy. Be intellectually curious, and don't commit to being an Eloi just yet. More recently, AI tools, whatever that even means anymore, write their code for them, the people that are developing all this stuff, and they may not even realize that the code is what the code is that it's writing for them. Maybe the result of training on some of the worst, buggiest, most insecure code out there. So the kid I was working with, the young person, he was graduating from high school. He didn't know how his computer worked. He had a MacBook, something. He knew nothing of the underlying hardware, how the computer functioned, etc. There were some other very bad practices. But he literally did. He just, it seems to work. We're done. Like, had no notion of the underlying systems and what was really happening. The classic, it works, versus a younger person who just says, it works, we're done, we're good, we're done, we're out. So it was interesting to watch that, and I've seen it a lot, and it's mostly, I'm not really interested in the underlying detail. I just want to be done and that's not how we got here. So yeah, the people that are actually building these tools don't have that attitude, but I'm sure it's amplifying this view of the world, such that they tell people now don't even bother getting engineering. Well, not all of engineering, but certainly computer engineering, even data science, I guess, is fading. But yeah, oh, you don't need to be a coder anymore. Psh, you don't even need to be a web designer anymore. You just tell it what you want. Yeah, make that a blue rectangle, and it will do it for you. Does anyone know, especially the junior or entry level people, they have code written for them based on crappy code. That's how large language models work. They're basically just pasting in stuff that they learned through the training process. So does anyone know about all this stuff? Do they know how it works? Do they even care? I don't think so. This will be a tough lesson in the near term, maybe a few fires to put out in the medium term as some of the bugs and issues linger from all that crappy code that's being put up the air quotes, written right now. In your travels, look up COBOL, 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 Common Business-Oriented Language. Someday, in your travels, I'm not going to do it here, see why so much important COBOL code is still running, because it works. Don't touch it. It works. And what happens when nobody knows how COBOL works anymore? COBOL is over 60 years old, arguably closer to 70, I think it is. We are seeing this happening in real time today as people abandon their computer science and engineering pursuits, and other fields are likely going to feel the same sense of uncertainty. So there are people who do write COBOL and maintain COBOL code today because they've learned it. But if you tell people, don't even bother learning how to program anymore, well, what's going to happen to all that COBOL code that handles trillions of dollars of banking transactions and so on? Nobody's going to know. Who knows? And there have been attempts to write AI tools that will translate the code into something more modern, and they don't really work. They don't work as well. It hasn't been a successful transition just yet. Maybe someday. In the meantime, we're not teaching young people how to program anymore. We've given up on that. Just have AI do it. And that is where you run into trouble, because 5 or 10 years from now, you'll say, oh, we need to fix this thing. Does anybody know any of these programming languages anymore? And ChatGPT will chime in and say, boy, I wish we would have gone public and stayed in business. But some AI tool will tell you, that's a great question. It will tell you how awesome you are. And then it will say, oh, I don't really speak that language anymore. Nobody writes code in that anymore. And all of the AI generated code has completely screwed up my training model. So, nope, can't help you. Now, personally, and I mention this all the time, it's not a secret, I use Google Gemini to generate cover art for this audio program and the others I produce each week, where I use it to varying degrees. Sometimes I create a background image. Sometimes I create an object to include in a background. Then I do the title text and some other elements. And and I composite the final image. So since I'm not really skilled in this area, I can't start from a blank canvas and create something lovely. I use a lot of clip art otherwise. I cannot imagine handing over something I can do and which I enjoy doing to a collective of tools of unknown provenance doing what might be a disservice on my behalf. Like, who wrote this code? It's garbage. Dan, your name is on it. No, it was DeepSeek. Surely the tools in my price range as I record this are capable of churning out some real slop. Can spending 1 million times or more on tokens and compute as compared to a normal human in their home office putting together a cover art image actually get something better? You can do a lot with the free tier. There are companies, as we're recording this, Uber famously burned through their annual AI tools budget in, I think it was 4 months, 5 months, may have been 5. So yeah, you're burning through it twice the rate, and there was already huge amounts of money. So it turns out, like, we could have just paid the employees we laid off to do this, and we would have understood as a company, we would have had some sort of knowledge about what we were developing. That knowledge would not exist in a prompt with the I don't want to say the mental capacity, but the actual process of developing our code in a data center somewhere on a server owned by someone else. So you don't even have company loyalty. You're building up tech debt. It's all delightful. So at what cost are we getting this stuff? I don't know. If nobody learns by doing when they are getting started early on, will they have any idea what they are doing or what their AI tools are doing for and to them 5 or 10 years from now? I have a doubt. So I myself am not anti-AI per se, but I do have dramatic reservations about just handing over code, or we're already seeing this at scale. People saying, "Oh, open source projects, I can contribute some code to an open source project, even though I don't know what I'm doing, because I'll just have AI write it for me." That's not good. That's not healthy. First of all, there's a fire hose of garbage now pointed at some projects. And then what good is that? If you can just submit some code that AI wrote for you and you don't understand, the people running the project can do that also. So you're not actually contributing anything. So you are dramatically reducing the progress, the effectiveness, the willingness of people to deal with you. So ultimately, not knowing what you're doing and handing it over to AI is a disservice to everyone. And let us hope that you don't ship your code, whatever it is you're working on. Use your AI to build a website that probably won't work as well as you hope it would. And then you won't know exactly what to change because you don't speak CSS anymore and you don't know what tags are. And you never worried about accessibility and all this other stuff that will become apparent over the next few years. I'm deeply concerned about this stuff. At the same time, I'm doing my part to keep the old ways alive. The way it is the way, it's still fine. The only reason people are trying to be faster and faster is because someone told them they need to be. All right, that's where I'm going to leave it for today. Thank you so much for listening, as always. I will tell you that this is 100% human written with some typos and everything. And I am an actual human speaking. I've thought about trying the voice clone stuff. If I was going to clone a voice, I would clone Anthony Bourdain and have him read my audiobooks to me or read text to me or whatever. Not that it's a dreamy voice, but I think it's a good voice for telling a story, going over a narrative. And if you're curious, I do love audiobooks. I think they're great. I listen to an audiobook while I'm out walking or at the gym or wherever. The value of an author reading their book is often, not always, but often a little extra something. So I've listened to the audiobook version of Kitchen Confidential several times. Anthony Bourdain tells a good story. And because it's his story, most of the book is recorded with the correct inflections and the correct emphasis and so on. Listen to Anthony Bourdain at 1.25 times speed and you will be rewarded. That's all I have to say. I will leave you with those final 4 words. I have a doubt. If you've ever seen The Fifth Element, you may have caught that, but I doubt it. But I still have a doubt. Take care, and we'll catch you next time. Don't forget to listen to all of my other audio programs. There are many. There are hundreds. So get comfortable, or maybe get on a treadmill. Go for it. Thank you. Take care. Until next time. Bye-bye.